Hello friends, welcome to this second video on autocorrelation. This video will deal with the problems using the properties of autocorrelation. Your part 1 video gave you an intro on autocorrelation and also the various properties which are applicable to autocorrelation. Come on, let's try to use them to solve problems in this video. The first problem is that check which of the following is going to be a valid autocorrelation function. You have been given a set of problems A, B and C. So we are to check whether which of the following is going to be a valid autocorrelation function. We will try to recollect that what are the properties of autocorrelation function which can suit us to identify whether they are going to be valid or not. So how can we check the validity of an autocorrelation function? What is the property we know about the autocorrelation function is that autocorrelation Rxx of tau is an even function, So what happens when it is going to be an even function? Rxx of tau equal to Rxx of minus tau for an even function. So if this property is going to be verified or tally for all the three of them, then I can suggest each one of them is going to be valid or not accordingly. So we will try with the first problem. This is my Rxx of tau. I am going to replace it with Rxx of minus tau. Wherever I have tau, I replace it with minus tau. So 25 into minus tau the whole square divided by 4 plus 4 plus 5 into minus tau the whole square. Minus tau the whole square gives you the same tau square. So it becomes 25 tau square plus 4 plus 5 tau square, which is the same as our Rxx of tau. So we know, verify that. First question is going to be a valid autocorrelation function. We will check the same thing for the second one. I am replacing the Rxx of tau by Rxx of minus tau. So I have cos of minus tau plus modulus of minus tau divided by t. Cos is going to be an even function. What do you mean by an even function? You know that cos of minus theta is going to be equal to cos theta. So cos of minus tau will again be equal to cos tau. And what is going to be modulus? Modulus is going to be any value that converts a positive as positive and a negative as a positive data. So what happens when I put anything inside modulus? It again receives me or gives me the positive data. So you will have divided by t, which is going to be the same as my Rxx of tau. So what happens? Second one is also a valid autocorrelation function. How about the third one? So let me replace the Rxx of tau by minus tau. So when I replace, what will happen? Minus tau the whole cube plus minus tau the whole square. What is minus tau the whole square? This is going to be positive tau square. Negative sign gets observed. But what happens when I have minus tau the whole cube? It is going to give me a negative sign of tau cube. Now what I have over here is positive tau cube, but what I have over here is negative tau cube. So can I say that it is the same as my Rxx of tau? No, it is not going to be the same as Rxx of tau. So C is not a valid autocorrelation function. So this property of your autocorrelation function, namely autocorrelation function is an even function of tau, will help you to identify whether the given function is going to be a valid autocorrelation function or not. So we will move on to the second problem. The second problem says that a stationary process has an autocorrelation function which is given by Rxx of tau is 25 tau square plus 36 by 4 plus 6.25 tau square. Find the mean and variance of the process. So what's the first thing we are going to compute over here? We are going to compute the mean of the random process. How to get the mean of the random process? It is given by the formula mu x, which is limit n tending to infinity Rxx of tau. So this is my Rxx of tau. I'll have to allow this tau over here and tau over here to tend to infinity. What will be infinity by infinity? Infinity by infinity is going to be an undefined process. So before allowing limit to tend to infinity, what we have to do is remove this tau square outside. So what will happen is the numerator will become 25 plus 36 divided by tau square. This is because this has a tau square, so you have taken it outside. This doesn't have a tau square, so that comes in the denominator. In a similar fashion, over here also you remove your tau square from over here. So you will have 4 divided by tau square plus 6.25. Now what will happen is this tau square can be cancelled as, and now when I allow my limit n tend to infinity to this quantity, what will happen is this is a constant and I will have 36 divided by tau square. So I will have something called as 1 divided by infinity as n tends to infinity, or like tau, limit tau tending to infinity. This is actually limit tau tending to infinity. So what will happen is as tau tends to infinity, 1 by infinity will move towards what quantity? It will move towards 0. So this 36 by tau square will move towards 0 and this 4 by tau square will move towards 0. So what will be left out of the process? I will be left out with just 25 in my numerator, and in the denominator I will have 6.25. So what will be 25 by 6.25? I know that this is going to be equal to 4. But what is going to be mu x? Mu x is nothing but square root of limit tau tending to infinity rxx of tau. So I have square root of 4. What will be square root of 4? It is going to be plus or minus 2. So I have first estimated the mean of the process. What is the next thing I require? It is going to be the variance. How to get the variance of the data? It is E of x square of t minus E of x of t, the whole square. This E of x of t is nothing but our mu x. So we have the mu x already. What we need to compute is just this first part. So how to get this first part E of x square of t? This E of x square of t is nothing but rxx of 0. So in the next step, what we are going to do is we are going to compute rxx of 0. So what happens in the rxx function? I am going to put tau as d0. So it is 25 into 0 plus 36 divided by, what is in the denominator? 4 plus 6.25. 4 plus 6.25 times of 0. So this vanishes, leaving us with 36 by 4. So this makes it as 9. So now my E of x square of t is ready, which is 9. Now computing the variance. What is the variance? E of x square of t minus E of x of t, the whole square. So we have 9 minus, what is E of x of t? It is going to be equal to, mean is going to be 2 plus or minus 2 the whole square. So you have it as 9 minus 4. So the answer is going to be 5. So this fixes the problem for us. In the second problem, we have to find the mean and variance of a stationary process with autocorrelation function. Rxs of tau equal to 25 plus 4 divided by 1 plus 6 tau square. We know that mean is given by the formula mu x equal to limit tau tending to infinity rxx of tau. But when we substitute tau as infinity over here, what will happen? We will have 25 plus 4 divided by 6 tau square. So this will become 6 times of infinity plus 1. So what will happen? This infinity times of 6 and this plus 1, everything in the denominator will now move to infinity. And we know that as we extend the limit tau tending to infinity, what will happen to 1 by infinity? 1 by infinity will move towards 0. Therefore, this entire of the quantity will now move towards 0. Therefore, as limit tau tends to infinity, what we will have is only 25, which will be left out. But what is mu x? Mu x is root over 25. So we will be having plus or minus 5. Now moving on to the variance part. How to get your variance? Variance is given by E of x square of t minus E of x of t, the whole square. So we will have to find the E of x square of t, which is given by rxx of 0. So wherever we have tau, we will have to put the tau as 0. So this E of x square of t will now take 25 plus 4 divided by 1 plus 6 times of 0. So this will become 0. 1 plus 0 makes it as 1. So it will be 25 plus 4 divided by 1. So now this will make it as 29. So I have the variance to be 29 minus mu x the whole square. So we have plus or minus 5 the whole square. Plus or minus 5 the whole square will be equal to 25. So 29 minus 25, that makes it as 4. So variance of the value will be equal to 4. And now moving on to the next problem, we have rxx of t comma t plus tau is 9 plus 4 e power minus 0.2 tau. We will have to determine the mean, variance and covariance of the random variable. Z is equal to x of 5 and w is equal to x of 8. So till now we have been doing with only mean and variance of the process given the autocorrelation. Now we have been given a random variable for which we have been asked to find what is going to be the mean and variance. Okay, so we will have to find E of Z and E of W when I want the mean of the random variable Z and mean of the random variable W. So what will be E of Z? E of Z will be E of x of 5. So what will be E of x of 5? So this is going to be wherever I have the value to be equal to 5, what is mean? Mean mu x is given by limit tau tending to infinity Rx of tau. So what will happen now? This whole square root is available. So this is my mean. So I will have to apply limit tau tending to infinity over here. Where do you have your tau? We have tau over there in e to the power of minus. What will be e power minus infinity? E power minus infinity will move towards 0. So when it moves towards 0, what will happen is, so this quantity will now become equal to 0, e power 0, 4 into 0 will make it as 0. So what will happen is, you will be having this 9 alone left out in your quantity. So you will be having square root of 9. So what will be the mean of the random variable z? You have it as to be equal to 3. Now, what will be E of W? E of W is going to be x of 8. So, how actually we have estimated this x of 5? X of 5 is nothing but the time difference between it. Tau has been given as 5 to me. Okay, so this value will now be the same whether we find it for the variable z or we find it for the variable w. That is whether it is going to be x of 5 or x of 8. What will happen? This tau, when I allow it to tend to infinity, this will have my mu. This is going to be mu z. Again, mu for w will also be the same square root of 9. Hence, it will be equal to plus or minus 3. Now, moving on to variance of z. Variance of z is e of z square minus e of z the whole square. To get e of z square, what we'll have to do? E of z square of t is got by equating rxx of 0. So I'll have to put this tau as 0. When I put tau as 0, what will happen over here? Tau is going to be equal to 0, e to the power of 0. What do you think e will power 0 be equal to? E power 0 is 1. So you will have this quantity to be equal to 1. So 4 into 1 makes it as 4, 9 plus 4. So 9 plus 4, that makes it as 13. So I will have variance of z to be equal to 13 minus, this is going to be mu z, which is going to be 3 the whole square. 3 the whole square is 9. So it is going to be 13 minus 9. So what will be 13 minus 9? We know that this is equal to 4. So variance of z is 4. And in a similar way, what will be variance of w? This, whether it is going to be 5 or 8, that is not going to matter. Hence, it is going to be the same e of omega w square minus e of w the whole square. So this will also be 13 minus 9, which is equal to 4. The change occurs over here when we are finding what is going to be covariance. So now we'll have to see what is going to be covariance of z comma w. So this is going to be the quantity which we require. We will have to recollect the formula for covariance. Covariance is nothing but E of zw minus E of z into E of w. Now what is this E of z? E of z is nothing but E of z of t into w of t. So this is nothing but R zw of your t. Okay, so what is going to be my tau over here? The time difference is what we have as input over here for, and this is going to be E of z into E of w. This will continue as such. Now we will look into the first part, RZW of tau. What we have for Z, we have Z to be equal to x of 5. Okay, and what we have for W, W is going to be x of 8. what is going to be the time difference between Z and W? This is going to be x of 5. This is going to be x of 8. So the time difference between them, tau, is nothing but equal to 8 minus 5. So what is my tau? Tau is going to be the time difference between Z and W, which is 8 minus 5 or 8 difference 5. What is 8 difference 5? 8 difference 5 is going to be equal to 3 for us. So where we will have to substitute this 3 now? This 3 will be substituted in place of tau over here because our tau is going to be 3. So what we will be having over here is, let me substitute 9 plus 4 e power minus 0.2 times modulus of 3. So this is what I have for my autocorrelation when the tau is replaced as 3. How do we get this 3? It is 8 difference 5 minus, what is this E of Z? E of Z is mean of Z, which we now know is going to be equal to 3. And what is E of W? E of W is also equal to 3. So this will be 3, this will be 3. This 3 3s are again makes it as 9. You already have a 9 in front. E power minus, this is modulus, so it is positive. So it is going to give me 0.2 into 3, so that makes it as 0.6. Plus 9 minus 9 cancels off, leaving you with 4 e power minus 0.6. So this is going to be the value for your covariance. So what we have estimated till now, we have estimated mean, variance and covariance of any given autocorrelation function using the properties of autocorrelation which we have studied. Thank you.